everybody. Welcome. My name is Moran. I'm a data analyst at Lusha. And today, I'm going to speak with you about topic modeling. So, what is topic modeling? Well, here is the definition from Wikipedia, but essentially, it's a process where you take a list of textual documents and you extract the main topics and the themes that occur within those texts. And there are many example use cases where topic modeling can be extremely beneficial. Here are just some examples. You might have a lot of feedbacks from your customers about your product, and they are given using free-form text. And you are interested at knowing what are the main complaints, suggestions, or even praises that are common at your customers. So you can use topic modeling. Maybe your organization have a lot of documentation and protocols and textual data, and you want to be able to divide it into topics so that employees can easily find what they are looking for. Another option is trend detection in social media. Maybe there's a community or a Facebook group and you are interested in knowing what are the main topics of conversation are. And also, the approach that I will be describing today can easily be extended to images or audio or basically any type of information that can be embedded into vectors. Now, I work at Lusha. And I personally have used the approach that I'm going to talk about today in order to analyze feedback from our customers and provide insights to decision makers that improve the product. And by the way, we are gold sponsors of PyData. We have a booth outside, and we are looking for talented individuals. So feel free to talk with me or with us. And well, anyway, for obvious reasons, I can't show actual feedbacks on our product, so instead, we're going to do something fun. I would like you to take a short detour from data and Python, and just for a few minutes, come to a trip with me at a place where many of us have already been as children or maybe teenagers. Hogwarts. The finest school in the land for witchcraft and wizardry. And if you are not familiar with Hogwarts, you basically need to know only two things. It's a school of magic, and the students at Hogwarts are divided into 4 houses based on their primary character attribute. You have the House of Gryffindor for brave students, Ravenclaw for smart students, good-hearted, loyal students go to Hufflepuff, and the evil go to Slytherin. And the reason that we are visiting Hogwarts today is because the new headmistress at Hogwarts is a very data-driven person. And she, for the past 3 years, have conducted a survey among the students of Hogwarts, and she asked them a simple question. What is the most substantial issue that you are facing in your day-to-day school life? And for the past 3 years, they have answered this survey, and a data set was generated. So let's, for example, see the second row. It's a student from Gryffindor at 2022. He reported, or she reported, what's up with the staircases? They change direction all of the time, and it's a total maze just trying to get to class. It's a valid complaint, but is it common? Or maybe this student is the only one that cares about it? Well, the headmistress wants us to perform topic modeling on this dataset and present to her and to the board of directors of Hogwarts what are the main complaints so that they can take steps to alleviate them. Now, traditionally, there are 2 ways to perform topic modeling. One is to do it manually, and that's okay if you have a small amount of texts to go through. Because yes, it's very accurate because human beings are very good with language. but also it's very time-consuming. Another option is to use one of many automated methods using Python that rely on word statistics. It can be as simple as looking at the most common words in all of the documents and maybe generate a word cloud, or it can be a very sophisticated statistical method like LDA. And it is automated and fast and efficient, but all of them sort of suffer from the same disadvantage. They fail to capture semantic and contextual meaning of words, phrases, and sentences. And by that, I mean, I'll give two examples for what I mean. Example one is that the words location and space can mean the same thing or very different things depending on the context. And another example is that it's good and it's not good share most of the words, but they mean completely opposite things. So, can we have the best of both worlds? Can we have a method which is both good at large scale, but also can capture contextual meaning of sentences? Yes, there is, and it's called BertTopic. So, what is BertTopic? It's a one-stop shop for topic modeling. It's a Python package, and it can understand contextual meaning because it harnesses the power of large language models, LLMs. It's important to note that it does not necessarily is using BERT despite of the name of the package. And also that as a design philosophy, it has a lot of built-in features that are designed to make our life as developers much easier. Here is a screenshot from the BertTopic webpage, and I won't have time to go through all of these functionalities today, but I invite you to go there and learn more and see what is best for your own specific use case. Now, let's go through a minimal viable example so that we can see just how easy and intuitive using BertTopic really is. First of all, you have to use pandas in order to load your dataset. In this case, a dataset of feedbacks from the students of Hogwarts. You create the BertTopic model. Obviously, you have to pip install and import it, but then it's just a matter of a single line. And you fit it to the data. Then you can ask the fitted model for information about the topics that it found. Let's see the pandas data frame, which is the result of this process. First, for each topic, it assigns an ID, starting from 0 and going upwards. -1 is for outliers. It's for texts that does not belong into any specific topic. It gives you the count of documents per each topic. It gives you a name that it generated, and later I will explain how, for each topic. So, for example, for topic 0, homework, potion's face. So you might be able to understand or guess what this topic is about. A representative list of words about the topic, and the keen-eyed among you will notice that the first 4 words in each representation also appear in the name. And don't actually try to read it all, but a sample of representative documents of that topic. And please keep the fact that it provides it in mind because it will come into play later. So this is a result of a topic modeling process. But it's not a very good result. Using those default parameters, we get a silhouette score of 0.25. If you are not familiar with silhouette score, or maybe you are, but you are not sure why is it used here, I will touch about it later, but for now, it's just a metric from 0 to 1, where the higher it is, the better our topic modeling is. The number of topics that the model found is over 200, and since I generated this dataset, I can tell you that the actual number is 10, so we are way off. And the percent of outliers is 21% out of the documents that does not belong to any specific topic. Again, In some datasets, that might be okay. Maybe it just has a lot of noise, but here it should be 0. So, can we do better? In order to do better, we need to understand how BertTopic works under the hood. BertTopic works through a process of 4 steps. The first step is to convert each document, each text, into an embedding vector. And I assume most of you are familiar with the concept of embedding vectors, but for those of you that are not, I will provide a very, very short, somewhat oversimplified explanation, just so you can keep up. In a nutshell, the idea is to convert each sentence, each document, into a list of numbers called vector. And the idea is that singular sentences that have singular meaning will have a singular list of numbers, while different sentences will have a very different list of numbers. The second step is dimensionality reduction. The process of dimensionality reduction is the process of taking data that is described by some amount of dimensions, here 2, x and y, and describe it using less dimensions, here only using the z dimension, while preserving as much information as possible. You can see that even using a single dimension, we can still tell that the blue dots are very similar to each other, but are very different from the red dots. And the reason that we need to perform dimensionality reduction on the embeddings from the first step is that usually the models that perform the embeddings from sentences into vectors have hundreds, if not thousands, of dimensions. That is, those lists of numbers are very long. And in such high dimensional spaces, the distances between vectors sort of lose their meaning. But we need well-defined distances between those vectors in order for the third step to work well. The third step is clustering. The idea here is to take a bunch of data points and automatically divide them into meaningful groups. Each is a cluster, where the data points in each group are very similar to each other, but are different from the data points in the other groups. So let's recap and tie it to topic modeling. We start with a list of feedbacks. We converted them to vectors that carry the similarity between sentences. We reduce the dimensionality of those vectors, and then on those shortened vectors, we perform clustering. Each such cluster is a topic. It's a collection of sentences that are similar to each other. Now, of course, there are many ways to perform embedding, dimensionality reduction, and clustering. So let's look at the default models that are used by BertTopic. For the embedding, it is using under the hood the Python package sentence transformers, which is using large language models from Hugging Face in order to embed the sentences. For dimensionality reduction, it is using UMAP, a powerful and very popular and relatively efficient dimensionality reduction algorithm that can capture non-linear relationships between the data points. And for clustering, it is using HDB scanner, which has, among others, a distinct advantage that you don't have to provide the number of topics in advance. It can give a reasonable amount of topics by itself, because in most cases, you won't know the number of topics in advance that exist in your dataset. But one of the most powerful elements of BertTopic is how configurable it is. You can replace any of those default models with any other models that you would like. You can use k-means instead of HDB scan. You can use PCA instead of UMAP, or whatever model that you would like. You can also configure the hyperparameters of the model that you chose. Now, there is one last step, and I will get to it very soon. So, now that we know how BertTopic operates, let's start to improve it. And the first thing that we can do is improve the embeddings. So I went into the Hugging Face website. I chose this sentence embedding model. And the reason that I chose it is because this is the best small model on the MTEB leaderboard, which is a leaderboard for models for sentence embeddings. And you can use whatever model that you like. If you have a model that you fine-tuned yourself on your own specific dataset, you can use it. But using this model, you create an embedding model using the sentence transformer package, this time explicitly, and you pass this embedding model into the creation of the BertTopic model. And the rest is the same. You fit it to your data, and you get a topic model which is fitted to your data. And this time, we get a significantly better result. The silhouette score is higher, the number of topics is lower, and the percent of outliers is lower as well. Now, let's again use this better embedding model, but tweak the hyperparameters of UMAP and HDB scan to be more well-suited to our data. Again, pass all of those models into the BertTopic model and fit it to our data. And now we get something which is good enough to be useful and to generate insights from. The silhouette score is significantly higher. The number of topics is 11, almost 10, almost what it actually should be. And the percent of outliers is almost 0. And the take-home message here is that BertTopic is sensitive to your modeling choices. And you'll probably have to do some iterative hyperparameter search in order to optimize it for your own dataset. So you can look both at numeric metrics, such as silhouette score, and you can look at the topics with your own eyes to check if they make sense to you based on your prior knowledge with the dataset. A word about silhouette score, if you're not familiar with it. The idea here is that a good clustering result will have short distances between each point to other points within its cluster, but large distances between it and the points in the nearest other cluster. If the ratio between them is high, it means that this is a good clustering. So, now that we have a model which is well-fitted to our data, what can we do with it? The most basic thing is just to look what are the most common and largest topics and what they are, using the representative words. And what are the names of the topics? Now, as you can see, homework potion's face is not a very good name. Maybe we can do better. Which brings us to the fourth and final step, naming. Now, by default, the way that BertTopic generates name, the way that it generated the names that you have just seen, is using C TF-IDF. C stands for cluster, a topic, and the intuition here is to check which words are very common within a topic, but are rare in all of the other topics. The idea is that those words are the best representative words for that topic. But maybe we can do better. Here is a function that I used in order to send the representative docs that BertTopic provides us and send it to ChatGPT. We ask it to create an intuitive and short name for the topic. In the rest of the function, there's a call to the API. And then you just take the representative documents, use the apply method of pandas, and pass the representative docs into this topic. If you have 10 topics, it's just 10 calls to the API. So now instead of homework potion's face, you have potion brewing disasters, which is a much better name. So let's start deriving insights. This is a table I created based on the topic model, which show you the percentage distribution of the houses per each issue. So for example, in the first topic, annoying enchanted textbooks, we can see that the house of Gryffindor is the most bothered by this issue. And already we can see two curious observations. One of them is that only the house of Hufflepuff is distracted by food smells. Maybe their dormitories are very close to the kitchen. Another one is that both Gryffindor, Hufflepuff, and Ravenclaw students complain about Snape, the potions teacher. But the house of Slytherin does not complain about him. Maybe the fact that Snape is the head of the Slytherin house has something to do with it. So we can take those insights to the headmistress, and she can take steps to address this issue. Now, part of what makes BertTopic so powerful is that it's very battery included. It contains plenty of functions to make your life easy. For example, visualize document data map, a single line of code that will give you this scatter plot. And the idea here is that clusters that are close together should have similar meaning. For example, we can see two clusters here, two topics here, with different shades of green. One of them is annoying enchanted textbooks, one of them is annoying sassy textbooks. Maybe we should merge them. Well, let's see the function visualize hierarchy that provides us with a dendrogram of the different topics so that we can see the distance between them. And we can see that topic 8 and topic 4 are very close together, and we might want to merge them. Merging topics is also a breeze. And by the way, you can hover over those merged topics in the dendrogram and get a generated name for them, which can act as another clue of whether you should merge them and is the merged topic make sense. Anyway, merging topics is a breeze. You just define a list of the topics that you want to merge and use merge topics. And the last thing that I want to cover is checking how topics are trending through time. Let's say that we only care about the complaints of the students at Hufflepuff. Well, we use the function topics over time. We provided the feedbacks of the Hufflepuff students as well as the years when those feedbacks were given, and visualize topics over time. We also tell the function to show us only the 3 most prominent complaints. And we get as a result this very nice plot that shows us how the topics were changed over time. For example, we can see that the green topic, gossiping portraits that are spreading rumors about the students, in 2022, it was relatively okay, but as time goes on, it becomes more and more pressing. So we can take steps to address the issue before it becomes even more significant. So, takeaways. Topic modeling is the process of finding the main topics in a dataset of texts. BertTopic is a one-stop shop for topic modeling. It is convenient and language aware. It uses LLMs to capture the semantic and contextual meaning of sentences. But it requires an iterative process of improving the hyperparameters to get a result that makes sense and is useful. And it has many built-in features for generating actionable insights. Well, this is it. Thank you for listening. Here is my Gmail. You can scan this QR code to get to my LinkedIn. And I'll stay here for a couple of minutes to answer any questions if you have some. Again, thank you.